All right, so we're going to talk about quotient properties today, and quotients are just the answer to a division problem. So nothing fancy about that, just the word quotient is related to the word product. Product is the answer to a multiplication problem. Quotient is the answer to a division problem. So we're going to talk about the properties of exponents when we're dealing with quotient properties. There's really only one true quotient property that we're going to deal with. The rest of them are related to the others that we've already talked about. So as we do this quotient property, there's really only one new one. The rest of them are just applying the product properties to the quotients. Okay, so there's only one new thing here. And when we're doing the quotient of a power, that would be something of a base. I'm going to use an A with an M as the exponent divided by the same base with a different exponent. When we multiplied, what did we do with exponents when we multiplied? When we multiplied A to the M times A to the N, what did we do with those exponents? Let's do one with numbers in it. X cubed times x squared. X to the fifth, right? Because you add the exponents. Okay, so it's M plus N when you're multiplying. So if you're adding when you're multiplying, the opposite of multiplying is dividing. What's the opposite of addition? Subtraction. So the exponent rule, the quotient of a power rule, the quotient rule is when you're dividing and it's got the same base, you subtract the exponents, top minus bottom. So it's A to the M minus N. So it's the top exponent minus the bottom exponent. Always in that order. Okay. Like the bases still have to be the same, just like they have to be to do these problems over here. The base has got to be the same. So here, if we do an example with some actual numbers in it, like x to the 7th over x cubed, really what we're supposed to do is subtract those exponents. So it should be the same base, x, and then we take 7 minus 3, which is 4. And obviously, again, that middle step is just what you're thinking. You don't have to write that step down. That's what you're doing, though. Is you're taking the top exponent minus the bottom exponent. Always in that order. Top minus the bottom. Now, let's do another one. Let's say we have a base of a -3 with an exponent of 5 and a base of a -3 with an exponent of 2. Are the bases the same? Yeah, they're both -3 as the base. So that allows us to do that quotient rule, which is do what with the exponents? Subtract 5 minus 2. So that'd be -3 to the 5 minus 2, 3. -3 to the third power. Okay. And we're just leaving it in exponential notation instead of standard right now. Say we had x to the 12th over x to the 7th. Just one more like that, and then we'll get into some other stuff. What do we do with the exponents? 12 minus 7. Why can we do that? It's the opposite of adding, and we're dividing. And why can we say why can we use that for this problem? What makes it legal? The base is the same. Very good. Very good. The base has got to be the same for that to happen. So 12 minus 7 would be x to the 5. Yeah. All right. So very easy rule. The quotient rule doesn't get any harder than that. It's always going to be, if the bases are the same, top exponent minus the bottom exponent. Okay, that's all it does. Okay. Now, where it gets a little tougher is when they start combining the other stuff back into it. Okay. So then that's where things get a little tougher. So let's start throwing some other stuff in there. And what we've got to remember is that when we're doing order of operations, you know, we do parentheses and then exponents and then multiplication and division left to right and then addition or subtraction. Well, we're not really doing any addition and subtraction right now. We're only doing multiplying or dividing, right? So we don't even have to worry about that last step. So when we're looking at a problem, we might have something like this: x to the fourth times x to the fifth, and then that's divided by x to the third. So we have a combination of a multiplication problem and a division problem all in one, okay? So when we're looking at order of operations, when I read that problem, what part of that problem do you read first? The top part. So that means it comes first, right? So when you're doing order of operations, what part should you do first? The top part or the bottom part? The top, right? So we're going to work that top part just the same way that we did a couple of days ago when we did the first exponent rule. So how do I do the top part? Add the exponents. That's exactly right. Several folks saying that. That's good. So that's going to give us x to the what on the top? 4 plus 5 is 9. And then we still got x cubed on the bottom. We hadn't done anything with it yet. Once we've done that, here's our new problem. Well, that looks just like the last three we did, right? So now what do we do with that? Yeah, and it'll be x to the 6th power. That's right. Exactly right. So we've combined a multiplication problem with a division problem. Do another one. Let's say we had x to the 10th times x to the 5th over x to the 7th times x to the 6th. Maybe a little more stuff. But it's still, you got to think, okay, well, what do I do first? Okay, add the top. So that's going to be x to the 15th on the top. Can I do the same thing on the bottom? Yeah. So it's kind of like you think, okay, well, I did multiplication up there. I bet I can go down here and do the multiplication too, because I'm doing the multiplication first, right? So 7 and 6 would be x to the 13. Not multiplying, we're adding those, remember, because they're multiplying. X, the same basis, and we add the exponents. Now, last step is the division problem. 15 minus 13 would be x 2, yeah, squared. We've done what looks like a pretty complicated problem. It's really not that bad. It's just 2 additions and 1 subtraction. It's not a hard thing. Let's say we had x to the 6th, y to the 3rd over x squared y. So they start mixing in a different letter in there, and we've got to keep in mind our rules for being able to do these exponent things. So F is a little bit different than E and D was, right? Because we don't have the same base on the top. One's an X and one's a Y, so they're very different things there. So can I add those exponents on the top? No, because the bases are not the same, so I don't do that. On the bottom, I look to see if I can do that as well. Can I add the exponents on the bottom? No, the bases are not the same, all right? So then I look to do the division problem because I couldn't do anything with the multiplication with the exponents and combine anything because they were different bases. So I look at the division problem and I look for the same base. What two go together? The two x's. These two go together, right? They're the same base. When I do that problem, what do I get? X to the, no. How do you do that? You subtract them, right? 6 minus 2 is 4, so it's x to the 4th. What about the y's? Yeah, I could do those, right? And it's division, so what am I going to do with them? Subtract them. And what's the exponent on this y in the bottom that doesn't have one? It's an understood 1 that's there. So when I take those two together, and I've got that 1 exponent, it's 3 minus 1, right? So that'd be y squared. And we end up with that answer. X to the 4th, y squared. Nothing else to it. Okay, so what we're trying to do is take this division problem and get the answer to it, get the quotient out of that. Do another one like that. Say we had x to the 11th, y to the 3rd over y squared x to the 6th. Well, they kind of mixed it up a little bit. Didn't put it in the same order. That's okay, because we know multiplication is commutative, meaning, you know, like 2 times 3 is 6, just like 3 times 2 is 6. No matter what order you do it in, it's the same thing. Okay, so when I look at this problem, I look, okay, is there anything that I can put together on the top or the bottom? Yeah, it's the same thing. If this problem written like this is the same thing as if I wrote it this way. So I don't have to rewrite it that way unless you want to. You don't have to, though. So that's like an extra step that you could leave out of that. But it works the exact same way. What Ty was saying, couldn't you cross that? Yeah, it's exactly the thing that you're doing. X to the 11th divided by x to the 6th would give us x to the 11 minus 6, 5. Okay. And then the y's can work the same way. We can kind of cross with that. 3 minus 2 would be 1, y to the 1st power. And I don't have to write that 1 on that. Just leave it just plain y. If you wrote the 1, it's not wrong. I don't think in Khan Academy, I don't think you need to type the 1 in if you needed to type in an exponent on something. If it's a 1, just don't put it. Okay. So they can rearrange the order and it still works the same way. Okay. Well, what if we kind of mix this with what we did, like on example C, where we might have something like x squared times y to the 3rd times x times y to the 5th over x to the, no, just x, y to the 4th. Something like that. So again, we're going to go through the process of looking at the top and saying, can I put anything together? Can I work anything out on the top? Yeah, I got some of them that had the same bases. I got an x squared and a plain x. So those are the same base. So when I multiply those two together, what do I get? X to the 2 plus 1 is 3. And then the y's, I got the same idea going there. I got y cubed, same base over here, y to the 5th. That'd be y to the 8th. On the bottom, I hadn't done anything. So that x has a 1 exponent. That's right. And then what do we do from there? Yeah, up and down. So 3 minus 1 would be x squared, y to the 4th. 8 minus 4 is 4. So we get our quotient out of that. Okay, so look to see if there's anything you can do to combine anything in the top or the bottom, and then do your subtraction on your exponents. Remember, the bases have to be the same to do any of that. If the bases aren't the same, you can't do it. All right. Let's see if we can do this. Let's take x squared y to the 5th over x to the 7th times x to the 8th y over y squared. All right, so here's where you got to have that working knowledge of how to multiply fractions together. And we spent a little bit of time working with fractions back in the beginning of the year to try to make sure we knew how to work with them. So every type of equation we did with fractions and decimals, and we did it with integers as well. So here we've got to think, okay, when I multiply fractions times each other, what are the rules? How do I do that? So if I were going to multiply, let's just take a number example to review that. If I said 2/3 times 5/7, what are the rules for multiplying those two fractions together? Say it again. No, that's only for adding and subtracting. Multiplying, I don't have to do that. It's easier. No, that's for adding and subtracting. Common denominators are not part of multiplying and dividing. Simplifying is always a part of fractions. How do you multiply two fractions together? Top and bottom? Top times top or top times bottom? Top times top, bottom times bottom. That is the basis of multiplying fractions. There are other things that we can do, but the whole start of it all is to multiply numerator times numerator, top times top, denominator times denominator, bottom times bottom. Okay, so for that number problem, it'd be 10/21. That's what that works out to be. Now for this, we've got x squared y to the 5th times x to the 8th y, and then on the bottom we got x to the 7th y squared. Okay, so we want to do that multiplication first and then do our division last. So on the top part, what can happen, because we're multiplying x squared times x to the 8th, x to the how much? 10th power, very good. X to the 10th, because they're the same base, we can add the exponents, and we're multiplying. Y to the 5th, and y would give us y to the 6th, because we have 5 plus 1. The bases are the same. We're adding. On the bottom, can we combine those exponents? Why not? Different base. Base is not the same. You can't put them together, right? So that's just going to be x to the 7th y squared. Okay. Once I get here, I can do my quotient rule. Subtract the x's. 10 minus 7 is 3. 6 minus 2 is 4. Say we had x y over x to the 3rd times x to the 4th y to the 5th over x squared y squared. We want another one like that, so we know we've got an idea about what's going on here. Okay. So I got a fraction times a fraction. So the way I multiply fractions together is what? Top times top, bottom times bottom. Okay. So x times x to the 4th gives me x to the x to the 5th. Y to the 1st times y to the 5th, y to the 6th. On the bottom, we got an x cubed and an x squared. That's x to the 5th. Y squared, there aren't any other y's on the bottom. So it's just going to come over there with it. Now, got to do our subtraction. X to the 0, y to the 4. Now, you said nothing. Technically, that's correct. They cancel one another out. Anything to the 0 power, this is one of those special properties of exponents. Anything to the 0 power, it turns into 1. Anything to the 0 power is 1. Technically, this is correct. I think in Khan Academy, you don't have to put the 1 because it's understood to be there. But the x's, when they're the same there, they're going to basically cancel each other out. And in fractions, 7 divided by 7 is how much? 1. Just like x to the 5th divided by x to the 5th is 1. It's the same thing on top and bottom. Okay? So multiplying fractions, look for the same bases Multiply across. Top times top, bottom times bottom. Hey? The y squared was here. It was here the whole time. And then it came over here. Because there wasn't one here, we just copied it over. That's where there wasn't anything else to add with it. Okay? All right. All right, let's look at what if they mix some numbers in there that are different bases instead of just all variables. We've had mostly just all variables here. So what if they mix in some numbers with that? And because it's fractions, that pulls in fraction rules for numbers. Okay, so here we've got 3x to the 5th divided by 6x squared. So we got this division problem. It's a fraction, but we're calling it a division problem. Which one of those could I do exponent rules with? The x's, right? Because they're the same base, right? That's the only thing. This is a 3, this is a 6. They're not the same, right? So those bases are the same. So that would give me 3x to the what? 3rd. 5 minus 2 is 3. I'm going to put that on top. And then I've got 3 and 6 there. What about the fraction 3 over 6? What do we know about it? It can simplify. How do you simplify a fraction? Look for numbers that go into both of them, right? What number goes into 3 that also goes into 6? 3. 3 goes into 3 how many times? 1 time. And into 6? 2 times. A couple of different ways you might write that. 1x cubed over 2, or you might write it 1/2 and then x squared, x to the 3rd power out the side of it. Either way is absolutely the same. Okay, or you might even write it x cubed over 2. That's also the same thing because it's an understood 1 in front of it. So it's the same thing. So there's several different ways to write those answers, but it's all in simplifying that fraction is what we're doing. Let's say we had 8 y to the 5th x squared 14 y to the 3rd x. What exponent rules can we do? X's and Y's are both the same base, right? So I can put those together using the subtraction rule that quotient rule does, tells us to do. So our X's, 2 minus 1 would be 1, so it'd be x to the 1st power. And I'm putting the x first because it's alphabetical order, and my brain says you need to put x first. It doesn't really matter. Okay, and I'm not saying you have to do that, but that's the way you're normally going to see the answer written with the variables in alphabetical order. Y to the 5th and y cubed would be y to the 2nd power, y squared. 5 minus 3 would be 2. Now we put both of those on top. That's where you should always put them to start off with. Next week we'll get into negative exponents, and we'll have to do some stuff with those. But always start out when you do that quotient rule with your answers on the top part. Now 8 and 14. Will that fraction reduce? How? Does 4 go into 14? No. 2 does. And does 2 go into 8? Yes. So we can divide both of them by 2 and get 4xy squared. 2 goes into 14 7 times. You might write this 4/7 xy squared. Either of those is absolutely the same thing. I would take either of those on a quiz for sure. As the answers. They're both the same. Okay. So if there are numbers there, you're just reducing them and working with them just like you would any other fraction. It's not any different there. We're not introducing any new rules to how we work with numbers. Okay. All right. Where things could get a little different, is maybe there's parentheses, and maybe they got x squared over y to the fifth. And then the outside the parentheses, maybe they put an exponent of 4. Okay. So if it were just like we did the other day, what's the rule for the exponents? If it were just this. Multiply. So that would end up being x to the 8th. It's no different here. The only difference is you've got a bottom part too. Everybody that's in parentheses gets this 4. So that's going to be x to the 8th and y to the 20. Everybody gets that exponent that's on the outside, always. Okay? Everybody gets that. Jack, you're putting your business all up in his face, man. Sit up. Sit up. All right, let's look at what if they throw a number in there, like 4x cubed, and then put parentheses around the top part, or let's do parentheses around the whole thing, over 3x squared, and then they raise that to the 5th power. Everybody gets multiplied by the 5 because order of operations tells us to do what first? Parentheses and exponents, right? So we're going to do that part first before we do anything else. All right. So that 4 is going to get the 5th power. That x on the top is going to turn into x to the 15. On the bottom, what's that 3 get? 3 to the 5th power, x to the 10th, right? Everybody that's in the parentheses got that exponent. Well, can I do anything exponent-wise with that? Or I don't have anybody that's got the same base? I got the x's got the same base, right? So I can do my quotient rule with that. Ends up being x to the 5th power. 4 to the 5th power is a number, and 3 to the 5th power is a number. So we're going to work those out. So this is exponential form. Let's get it in standard form, which remember means work out the numbers. So 4 to the 5th power means 4 times 4 times 4 times 4 times 4. So that's a pretty big number. So it'd be 64 times 64 times 4 is what it's going to be. So 64 times 4 is going to be 256 times 64, and I'm just going to do that out. 4, 32, it'd be 22, 8, 9, 10, and then 6 times 6 is 36, 33, 12, 15, 1, 6, 3, 8, 4. So 16,384 x to the 5th. 3 to the 5th power, not quite as hard. We know that 3 to the 4th power is how much? We've done that one a few times the last couple of days. Three times 3 is 9. 3 times 3 is 9. What's 9 times 9? 81 times 3. What's 3 times 8? 24, right? So 3 times 80 would be 240, right? What's 3 times 1? 3. Add those together, 243. You can do math in your head. You've got to practice it, though. It just takes time of practicing it and not picking up a calculator. It can be done in your head, though. There are ways to make the problems easier. And I always kind of try to look for those ways and model those to you. How that. So here, exponential form, standard form. That's the only difference in those two. Same answer, really, though. All right. Let's look at another one. You're getting close to the end here. Not much further. All right. say we had 4x cubed, parentheses squared, over 2x, parentheses cubed. So two different sets of parentheses here instead of just one. But they're both tied inside of parentheses first, right? I gotta do the exponents on the outside before I can do the bases being the same. So the top part's going to be what? X to the 6th, 3 times 2. On the bottom, we're going to have 2 to the 3rd, x to the 3rd, because it's 1 times 3, right? Now we can do the x's. Those have the same base, and now we can work those. So that's going to give me 4 squared x to the what? 6 minus 3 is 3. And then we have 2 cubed on the bottom. So there's exponential form. Standard form, what's 4 squared? Which is 16, x to the 3rd, 2 to the 3rd is 2 times 2 is 4, times another 2 is 8. Does 16 over 8 reduce? Yeah. How many times will 8 go into 16? 2 times 2x to the 3rd. Technically, it's over 1, but you don't have to write the over 1 part. Remember, it's just 2x to the 3rd. So, simplifies out pretty nice there on that one once you go to standard form. So, that's one of the reasons that we would go to standard form, is we could see that number reducing if possible. The previous problem didn't reduce at all. You wouldn't have. Okay, so it takes a little time there. All right. If there's anything, we've done examples like these. I don't want to bore you doing the same thing over and over, so I'm not going to do that. All right, so that ends up